So many strange and lovely things exist far beyond our planet that it can be difficult to believe they even exist. Black holes are maybe the strangest of them all. They are one of the most searched terms in our universe. It is exciting to consider a region of space with such a powerful gravitational pull that nothing can escape its deadly grasp. A black hole is a large and compact entity with such tremendous gravity that not even light can escape it. While we've never seen a black hole up close, we do know they exist and have some strange consequences on space and time. We don't yet know everything there is to know about black holes, but we do know whether or not anything comes out of a black hole or whether a black hole stays at the same place in the universe or not. So let's look into the darkness and see what we can, while busting some myths in the process. Black holes are huge. Some black holes are huge in size. The dimensions of supermassive black holes are measured in tens of millions of kilometers. However, this isn't a given. Black holes with masses comparable to our sun's can also be exceedingly small. In fact, astronomers discovered a black hole in 2019 that was merely 19 kilometers across. All black holes are about the same size. Black holes appear in a variety of sizes, which are determined by their mass. Small black holes are frequently the consequence of a star collapsing quickly and violently. Intermediate black holes have been discovered in the nuclei of some active galaxies, according to new research. On the other hand, supermassive black holes can be discovered in the center of practically every galaxy. All stars become black holes. Massive stars run out of fuel and collapse in on themselves in a violent implosion, forming stellar black holes. However, not all stars pass away in this manner. A star of medium or small size as our Sun will become a white dwarf, a stable, low-energy star with insufficient mass to collapse into a black hole. The star either becomes a neutron star or a black hole if it is much larger. As a result, neither our Sun nor the vast majority of stars in our universe will eventually become black holes. Nothing comes out of a black hole. Nope, it turns out that a black hole can emit radiation. A theory that a black hole is not as dense in a quantum mechanical sense was one of Stephen Hawking's contributions. The black hole would simply vanish over time as a result of the continuous emission of what is now known as Hawking radiation. Black hole's supergravity will pull you into its center. You can get pretty near to a black hole, it turns out. You may get as close as tens of miles to a black hole with a mass equal to our Sun. Consider what would happen if we replaced our Sun with a black hole of equal mass. All of the planets would still continue to circle around it at their current speeds and distances. The universe will be consumed by black holes. You can exhale a sigh of relief because this is unlikely to happen. In the future, the cosmos will go through different transformations, but they will take trillions of years. Hawking radiation causes black holes to slowly dissipate over trillions of years. As a result, in this version of the universe's fate, all of the stars will gradually fade away, and no new stars will develop. Event horizons cause spaghettification. Because gravity becomes more powerful as you get closer to a black hole, a person who approaches it feet first may find that their feet are pulled quicker than their heads and their sides are crushed inwards. The effect would be worse as they approach the black hole until they are eventually shredded into a string of individual atoms in a process known as spaghettification. While scientists believe that spaghettification is a real phenomenon, generally it is believed that it occurs at the event horizon of every black hole. However, depending on the size of the black hole, the point at which spaghettification occurs varies. You could easily pass the event horizon without being spaghettified for the largest supermassive black holes, and you might not even realize you've done so. In these circumstances, spaghettification would not occur until much after the event horizon had passed. Black holes will suck everything. Luckily, this isn't likely to be the case. This is due to the fact that you must be very close to a black hole to feel its gravity, and gravity weakens as you approach further away. If the sun could somehow transform into a black hole, which it can't as we've already explained, all of its contents would be overloaded into a tiny volume of a few kilometers across. Black holes evaporate. Black holes are predicted to eventually evaporate by releasing particles through a process known as Hawking radiation if given enough time. Small black holes are expected to vanish fairly instantly, whereas larger ones are expected to take much longer. As a result, it's expected that our universe will eventually enter a black hole age, when stars cease to develop and have mostly burnt out, and the universe would be dominated by these huge black holes that slowly evaporate. Despite the fact that Hawking radiation has yet to be scientifically proved, it is largely accepted among scientists today, since it fits nicely with what we know about physics. All black holes are black. Light can be detected near a black hole's event horizon, as shown by a photograph taken by the Event Horizon Telescope. This is the line that separates normal space from the space influenced by the black hole's gravity, from which there is no escape. Some of the light comes from the black hole's acerration disk, a flat, pancake-like structure composed of dust, gas, and other debris. The material of the disk is constantly being pushed inward toward the event horizon by friction, which accelerate materials outward along the disk's north and south poles, also emit light. Black holes stay in one place. It's simple to expect a black hole as a fixed point in space-time that pulls all neighboring stuff inwards to reach its end. That, however, is not the case. Black holes, like stars, planets, and everything else in the universe, are mobile. In fact, two black holes colliding and merging produced the first gravitational waves discovered in 2015. The two orbited one another, swirling closer and closer until they collided with a bang. Did we happen to bust any of your myths behind black holes? Let us know in the comments below. Don't forget to smash that like button, subscribe to the channel, and hit the bell icon to be notified of our future videos. And we will see you in the next one.